Hello everyone, welcome to Akshara IIT Foundation. This is Synop, your maths faculty. Let us move to the today's class. Yeah. Today we are in geometry topic synopsis 7, nothing but about quadrilaterals. Okay na? So first of all, let us discuss about a quadrilateral. Okay. So what is quadrilateral? Quadrilateral is nothing but a simple closed figure bounded by 4 line segments. A simple closed figure bounded by 4 line segments or a polygon with 4 sides. A polygon with 4 sides is called a quadrilateral. Okay, na? A polygon with 4 sides. Okay, right. Now, polygon with 4 sides. Mainly, the quadrilaterals are two different types. First one is convex quadrilateral and second one is concave quadrilateral. Okay, we discussed already what is a quadrilateral. It is a polygon which is bounded by 4 line segments or 4 sides. So for example, if you take a quadrilateral 1, 2, 3, 4 sides. So let us name it as ABCD. Okay, na? Here ABCD are called vertices of a quadrilateral. What do you call? Vertices of a quadrilateral. So point A, point B, point C and point D. Okay, right. And AB, BC, CD and AD. These line segments, A to B is a line segment, AB line segment, BD line segment, CD line segment and AD line segment. These 4 line segments are being as a sides of quadrilateral. So what are the sides here? There are 4 sides, nothing but AB, BC side, CD and DA. Okay, na? So 4 vertices, 4 sides, and there are formation of 4 angles also. Angle A, angle B, angle C and angle D. These are angles. Angles is nothing but angles are formed at common point of 2 sides. Okay, so we can write it as angle A, angle B, angle C and angle D. Okay, na? These are called parts of a quadrilateral. Sides and angles are called parts of a quadrilateral. Okay, now if you want to take any point inside the quadrilateral, if you take any point inside the quadrilateral, these points are called interior points of a quadrilateral. P and Q are called interior points of a quadrilateral. And if you take outside of the quadrilateral like X and Y, these 2 points are being exterior part of a quadrilateral. P and Q are inside a quadrilateral, we can call interior points of quadrilateral. X and Y, exterior part of a quadrilateral, nothing but exterior points of quadrilateral. And here while you are observing A, B, C, D, these are exactly being on boundary of a quadrilateral. So the points belongs to quadrilateral always on the boundary of a quadrilateral. A, B, C, D are belongs to quadrilateral. So P and Q only interior point and X and Y are exterior part of a quadrilateral. Okay, na? Right. Now about the quadrilateral we know already. Sum of all angles of a quadrilateral is 360 degrees. When you compare with the triangles, sum of interior angles of triangle is 180 degrees and same way sum of interior angles of quadrilateral. Interior angles of quadrilateral is 360 degrees. Okay, na? And if you take any closed figure, the exterior angles of a quadrilateral, sum of exterior angles is always 360, whether it is a triangle or any type of quadrilateral, pentagon, any type of closed figure. Sum of exterior angles always will be 360 degrees, but sum of interior angles will be changes according to their sides. Okay, na? So we have triangle sum of interior angles 180 degrees, but in a quadrilateral sum of interior angles is 360 degrees. Clear till then? Right. So we discussed that Quadrilateral, mainly two types of quadrilaterals are there. So first one is convex quadrilateral and concave quadrilateral. There are two different types, convex quadrilateral and concave quadrilateral. Sir, what is convex quadrilateral and what is concave quadrilateral? For example, let us discuss two more points in the about a quadrilateral. Like we discussed about the interior points, exterior points, sum of interior angles of quadrilateral, vertices we have discussed, angles we have discussed, and sides of quadrilateral also we discussed. Now we need to discuss about the diagonal of a quadrilateral. What is that? Diagonal. Diagonal means the line segment which is connected to two opposite vertices. The line segment which is connected to two opposite vertices is called a diagonal. Okay, na? Here DB line segment is called diagonal of quadrilateral. AC also diagonal of this quadrilateral. There are two diagonals for quadrilateral. Okay, na? Right. Now about the convex quadrilateral. It is also a simple closed figure bounded by four line segments, but when you take the quadrilateral, we can say the convex quadrilateral like the diagonals always interior part of a quadrilateral for convex quadrilateral. For concave, it is not needed for every time. So sometimes, every time the diagonals being exterior part of a quadrilateral. Okay, na? Or simply sum of opposite angles in a quadrilateral are less than 180 degrees or 180 degrees. But in concave quadrilateral, sum of interior angles, opposite interior angles is more than 180 degrees, greater than 180 degrees. Here in convex quadrilateral, sum of opposite angles is lesser than or equals to 180 degrees. But in concave quadrilateral, sum of opposite angles more than 180 degrees. Okay, na? So, or else if you take ABCD is a quadrilateral, the BD line segment, BD is a diagonal, the BD is line segment is being inside of a quadrilateral ABCD. Same way AC also inside of a quadrilateral. But when you take that concave quadrilateral will be like this. So, four-sided line segment AB, BC, CD and DA. Now when you join that opposite vertices, AB line segment is called diagonal. In this case, diagonal is interior part only, but here lying exterior part of a quadrilateral. So that's why we can call this type of quadrilaterals as concave quadrilaterals. Okay, na? Sum of opposite angles are more than 180 degrees here, but here less than or equals to 180 degrees. Clear? Yeah. Now we need to discuss about the convex quadrilateral in this topic. Convex quadrilateral again divided into 6 types of quadrilateral. First quadrilateral is trapezium. First one is trapezium. Second one parallelogram. Third one rectangle. Fourth rhombus. Fifth one square. And last one is kite. Okay, na? So the four-sided polygon is called quadrilateral and sum of all its interior angles is 360 degrees. Again in this quadrilateral are divided into 2 types of quadrilaterals, nothing but convex quadrilateral and concave quadrilateral. So convex quadrilateral means the diagonals of a quadrilateral always being inside or interior part of a quadrilateral are called convex quadrilateral. Here concave quadrilateral, the diagonals never be interior. Both the diagonals never be interior part of a quadrilateral. Okay? Now in the convex quadrilateral, there are 6 types of quadrilaterals. So in this topic, in this synopsis, we are going to discuss all the properties of these 6 quadrilaterals. And based on the properties, you are having some questions related to the properties. Okay, na? So let us move to the one by one. So mainly 6 type of quadrilaterals. Let us discuss it here. Now, first one, trapezium. What is trapezium? Trapezium also a quadrilateral, but it is having a property, that is, how can you identify it is a trapezium? From set of 6 quadrilateral, how can you definitely identify a quadrilateral trapezium? Trapezium is nothing but one pair of opposite sides parallel. In a quadrilateral, one pair of opposite sides are parallel. Okay, no? That means we can draw a trapezium like, I am taking a pair of parallel sides. These two are parallel lines and I am joining like this. So there is a formation of trapezium. Yes, it is a trapezium. So if you name it as ABCD, AB and CD are parallel. These arrow marks indicates the parallel lines or parallel sides. Okay, no? So this is a trapezium. Or if you want to draw the trapezium like this also. Take any two parallel lines, one pair of parallel lines, and join like this. Yes, it is also a parallel trapezium. It is also a trapezium. We need only one pair of parallel sides in a quadrilateral. Okay? So such type of quadrilateral is called trapezium. In trapezium, sum of angles between parallel lines are supplementary. Sum of angles, the property is sum of angles between parallel lines. Supplementary is nothing but 180 degrees. That means from this diagram we can say that angle A plus angle D. Only these two angles are lies between parallel lines. These two are 180 degrees. Same way B and C also. Angle B plus angle C also 180 degrees. But angle A, angle B never becomes parallel, never becomes 180 degrees because they are not lies between the parallel lines. Okay, na? Right. So sum of angles between parallel lines is 180 degrees. That is main important property of a trapezium. Okay, na? Right. Now let us discuss one more point. In a parallelogram, I told you one pair of parallel sides. And what about the remaining two sides? The remaining two sides are called non-parallel sides. Remaining two sides are called non-parallel sides. On these non-parallel sides, take midpoints. So for this AD and BC are non-parallel sides. On this AD, I am taking a midpoint P. Here I am taking a midpoint Q. And join both the midpoints PQ. Here PQ is called median of trapezium. PQ is called median of trapezium. That means the line segment which is connected to midpoints of non-parallel sides of trapezium. These two are connected to midpoints of non-parallel sides of trapezium. Then this line segment PQ is called median of trapezium. Okay, na? Now to find the length of median, we are having a formula, that is median length equals to, that means PQ equals to sum of parallel sides AB plus CD by 2. The length of median equals to, in a trapezium, the length of median equals to sum of parallel sides by 2, or half of the sum of parallel sides. Okay, na? Right. Now to find the area of trapezium, we are having a formula. Area of trapezium equals to half of h into a plus b. Now here A and B are nothing but length of parallel sides. A and B are nothing but length of parallel sides, and H is distance between parallel sides. H is distance between parallel sides. Okay, na? So till then we have discussed about one of the quadrilateral trapezium. Nothing but one pair of opposite sides are parallel in a quadrilateral is called trapezium. In the trapezium, one pair of non-parallel sides also there. In that non-parallel sides, if you take midpoints, the line segment connected to the midpoints of non-parallel sides is called median of trapezium. To identify the length of median, we are having a formula like PQ is equals to AB plus CD by 2, where AB and CD are length of parallel sides. Okay, na? Length of parallel sides. Now area of trapezium is equals to half H into A plus B. H means distance between parallel sides. A and B are called length of parallel sides. This is about the trapezium. Okay, so let us move on to the parallelogram. The definition is very important here. One pair of opposite sides parallel. Now in parallelogram, second one, parallelogram. Okay, so the definition is two pairs of opposite sides. Two pairs of opposite sides are parallel. In a quadrilateral, two pairs of opposite sides are parallel is called parallelogram. Here how many pairs? Two pairs. One pair means trapezium, two pairs means parallelogram. Now I am taking two pair of parallel lines. So these two are parallel lines. Again, these two are parallel lines. So first pair of parallel sides, second pair of parallel sides. So this diagram is called a parallelogram. This diagram is called parallelogram. That means in a quadrilateral, two pairs of opposite sides are parallel is called parallelogram. So A, B, C, D is a parallelogram. Now here we have very important properties are there for parallelogram. The first property is opposite angles are equal. In a parallelogram, opposite angles are equal. What are opposite angles here? If you take angle A is equals to angle C, because A and C are opposite to each other. Same way, if you take B, angle B equals to angle D. So opposite angles are equal in parallelogram. Now second property, opposite sides also equal. Opposite sides also equal. That means AB length equals to CD length. AB distance equals to CD. Same way BC distance equals to AD. Opposite sides also equal. Now third property, diagonals bisect each other. Very important. Diagonals bisect each other. Third important point is diagonals bisect each other. What are the diagonals? Diagonals are nothing but the line segment joining opposite vertices of a quadrilateral. Now B and D is BD is a diagonal, AC is a diagonal. Okay, na? So diagonals bisect each other. Bisecting means bisect means divide into two equal parts. Divided into two equal parts. That means AC and BD are connected to, are intersecting at O. Let us take the letter O. That means OD distance to OB distance equal. That means BD diagonal divided into two equal pieces. Same way AO, OC are equal. Diagonals are bisect means OD length equals to OB length, AO length equals to OC length. These three are most important properties of a parallelogram. Okay, na? What is that? Opposite angles are equal, opposite sides are equal, diagonals bisect each other. Now, fourth property is sum of adjacent angles supplementary. Sum of adjacent. Adjacent means side by side. Sum of adjacent angles is 180 degrees. Okay? That means angle A plus angle B equal to 180, angle B plus angle C equals to 180, angle C plus angle D equal to 180, and angle A plus angle D also 180. Sum of two adjacent angles, sum of any two adjacent angles are 180 degrees in a parallelogram. Okay, so mostly these 4 points, 4 properties are there for parallelogram. But here trapezium only one property, sum of angles between parallel sides or parallel lines is called supplementary, nothing but angle A plus angle D equals to 180, angle B plus angle C is equals to 180 degrees. Okay, now please have a look at. Then we'll go to the next one. Okay, right. Now, third important quadrilateral is nothing but a rectangle. Third one is rectangle. Okay, na? Check. So, rectangle, rhombus, square. Except the trapezium, if you leave the trapezium here, parallelogram, rectangle, rhombus, square. These 4 belongs to parallelogram properties. Parallelogram family we have to remember like that. That means when you take that rectangle, rhombus and square, these 3 all are coming from the parallelogram diagram or coming from the quadrilateral is parallelogram. That means rectangle also a parallelogram, square also we can call it as a parallelogram, rhombus also we can call it as a parallelogram because these are all following the properties of parallelogram. That means the square, rectangle, rhombus all are having the properties of rectangle. So we can consider these 3 as from a family of parallelogram. Okay. Now rectangle. So that's why while you are writing the definition of the rectangle also, we are writing that in a parallelogram. We can write like this also as a shortcut for parallelogram. Parallelogram we can write it as in a shortcut method also. In a parallelogram, each angle or one angle, any one of the angle. In a parallelogram, one angle is 90 degrees. If any one of the angle becomes 90 degrees in a parallelogram, that parallelogram is converted or transformed into the rectangle shape. Okay, na? That means, first of all, while you are observing these 2 sides are somewhat slant like this, when you make that 90 degrees angle, they will become as a, or they will transformed as a rectangle. That means the same parallelogram, the parallel sides like this, parallel sides, they are transformed into rectangle. Okay? This parallelogram is transformed into rectangle. That's why it is having each angle or any one of the angle is 90 degrees. Okay? Right. Now, what about the properties? What about the properties? All these 3 properties or these 4 properties are same. Opposite angles are equal, opposite sides are equal, diagonals bisect each other, and sum of any 2 adjacent angles is supplementary. Okay, and extra point, extra property is, or 4th one or 5th one, you remember that in a rectangle, length of diagonals are equal. In a rectangle, length of diagonals are equal. Okay, so if you observe that the rectangle like ABCD, it is also one of the parallelogram. Okay, so the parallelogram just is transformed its position to rectangle when it is takes the one of the angle is 90 degrees. That means it is having all its own properties as it is. That means it is following all the parallelogram properties like opposite angles equal, opposite sides equal, diagonals bisect each other. Here also diagonals bisect each other. Sum of any two adjacent angles 180. These four properties along with extra property because it is transformed a little bit. So that's why the length of diagonals are equal. But your length of diagonals are not equal. So BC length is somewhat longer and AC length is shorter than BC. But here length of diagonals are equal. We should take it as AC equals to BD. AC length equals to BD length. Okay now? Right. Now let us move on to the fourth one. Fourth one is nothing but a rhombus. Now rhombus. Rhombus also from the family of parallelogram picture, a parallelogram quadrilateral. So we are taking the rhombus definition as in a parallelogram all sides are equal. In a parallelogram all sides are equal, it will become a rhombus. It is also a parallelogram, but while you are observing in a original parallelogram, it is having opposite sides only equal. But here, when you transform the parallelogram into all sides equal, it will become a rhombus. Okay, na? All sides are equal, will be rhombus. The parallelogram will be a rhombus. Okay? All sides are equal. So AB length, BC length, CD length, DA length. All sides are equal in a parallelogram becomes rhombus. So same way we are using the definition, we are using the word parallelogram here while telling about the definition of rhombus. So that means we should consider all the properties of parallelograms are applicable here. That means opposite angles equal. Angle A is equals to angle C. Angle D equals to angle B. All sides equal means opposite sides also obviously equal and diagonals bisect each other. Diagonals bisect each other. Diagonals bisect each other. Okay? And sum of adjacent angles also supplementary, same. All these 4 points. And when it is somewhat changes, like rectangle is changing into a straight position, that's why the length of the diagonals are equal. But here there is a small change, that is all sides are equal here. Here the small change is the diagonals bisect perpendicularly. Perpendicular means both the diagonals are making 90 degrees angle at the point of contact or at the point of intersection. Okay, na? Please have a look on them. So we discussed about a trapezium. In trapezium we discussed about the properties of trapezium and area formula of trapezium and median of a trapezium also. Now coming to parallelogram, we need to discuss area formula. Area of parallelogram is base into height. Area of parallelogram is base into height. Base means if you take any of the side, but height means it is an altitude which is drawn from vertex to its opposite side. For example, if you take that CD as a base, from this CD we should take 90 degrees angle from A. We are making 90 degrees angle. Now AE. AE will be the height. Simply the distance between parallel sides related to the base. Distance between parallel sides related to the base. Okay, na? So area of parallelogram equals to half base into height. Now what is that area of rectangle? Area of rectangle we already know that is length into breadth. L into B, length into breadth. Now area of rhombus. Area of rhombus is half base into height, sorry, half D1 into D2. Here D1 and D2 are nothing but the length of diagonals AC and BD. Length of diagonals. D1, D2 are length of diagonals. Okay, na? So till then we have completed 4 quadrilaterals. So except the first one, remaining 3 are following the same properties like parallelogram, and somewhat extra properties are having for rectangle and rhombus. Okay, so let us move on to the next type of quadrilateral, nothing but square. Nothing but a square. Yeah, so let us discuss about a square. While you're taking the square, square definition will be given from the rhombus. Okay, na? So in a parallelogram, all sides equal becomes rhombus. In a rhombus, square definition is in a rhombus, any one of the one angle becomes 90. Parallelogram, one angle 90 degrees becomes rectangle. Rhombus, one angle becomes 90 degrees is called a square. Okay, na? So that means the slant position again transformed into the square position like this. So ABCD is a square. ABCD is a square. Okay. That means in a rhombus having one angle 90 degrees, it becomes a square. So as it is following all the properties of rhombus. Opposite angles equal, opposite sides are equal, diagonals bisect each other perpendicularly. Rhombus having the diagonals bisect each other perpendicularly, and extra whenever it is having 90 degrees, length of diagonals equal. Length of diagonals equal. Okay, now area of a square. A square is equals to a square or side into side. A square or side into side. Okay, na? So this is about a square. Clear? Yeah. So today we have discussed about a quadrilateral is nothing but a polygon which is bounded by 4 line segment. A polygon with 4 sides is called as quadrilateral. There are mainly 2 types, convex and concave quadrilateral. Convex quadrilateral, sum of opposite angles are lesser than or equals to 180 degrees. In concave quadrilateral, sum of opposite angles are more than 180 degrees. Okay, na? In a convex quadrilateral, again there are 6 types of quadrilateral: trapezium, parallelogram, rectangle, rhombus, square, and kite. We have already discussed about 5 out of them. Out of the 6, we have discussed 5, and their properties also we discussed, and their areas also we discussed. Okay, so we need to discuss about a kite. Last one is kite. That one we'll discuss in the further classes. Next class, just you revise all the properties of the quadrilaterals and their areas formulas, and what are the situations or what are the diagrams or each diagram for each quadrilateral I have told you. So just practice. That's it for today, children. Thank you one and all. Have a nice day. Bye bye.